Hello, so this is an introduction to RStudio designed for O6C students. I can apologise for production quality. I have absolutely no expertise in making screencasts at all. I'm just messing about in my kitchen with a webcam, a glass of wine and a little bit of enthusiasm. So if you have trouble listening to me, then just turn the sound off and read the script here, which is an unhesitating version of what I'm trying to tell you. Okay, so how do we get R started? If you're on a campus PC, then you need to start RStudio from the Start menu down in the corner. I'm on my own laptop here, so I don't have a Start menu. And search for RStudio in the programs. So you'll find it actually under Maths and Stats. And you want to make sure you start RStudio and not native R. So I'm going to start it from the taskbar here. And when it starts up, I have here the console window. So the console window is where you type commands that you're going to send to R. So you will have typed commands in for the data camp tutorials. So I can create a vector, which I'm going to call vec1, easily like this. And I'm just choosing any old numbers here. And you can see now that vec1 has appeared in my environment. So the environment is the environment window tells you what you have in your workspace. And the workspace is just somewhere to store all the data structures and functions that you've created during this session. So we can create another vector, which I'm going to call vec2, in exactly the same way. I'm going to give it some different numbers. And then I'm going to add those two vectors together. And that's going to print the output to the screen. So it's adding 2 and 3 to get 5, 5 and 6 to get 11, 1 and 1 to get 2. So that's moderately useful. And if you want to see what would happen if you make a mistake, let's suppose I accidentally miss out the 2. So instead of writing vec1 plus vec2, I'm just going to write vec1 plus vec. And now you can see I get an error because there's no such object as vect. If you look in your global environment, there's nothing called vect, so it doesn't know what you're talking about. So we want to correct our error, and the way we can do that is to use command recall using the up arrow on the keyboard. So if I use the up arrow, it'll give me the previous command, and I can edit that command wherever I like, and then send it again, this time correctly. So it's easy to correct commands, and if you want to see commands that you did more distantly past, you can either press the up arrow more times, or an easier way is to use the history. So the history gives a record of every single command that you've written in that session. So here we have that command that was correct, the last one, and the one before it is the incorrect command. So having a record of every single thing you typed in is partly useful, but it would be more useful to have a record of everything you typed in that was correct. And this is where a script file comes in. So in order to create a script file, you press this plus button here, create a new script file, and a file will open above the console window. And here you can type your commands instead of at the console window and then send them to the console window. So if I now type vec1 plus vec on its own, and I click run to send that, I obviously get the error. Whoops. Down here, because there's no such object as vect. But I can then correct my script file by putting the 2 in and then run the command again. This time it runs correctly. So in the history, both those two commands are showing, oops, that one and that one, whereas in the script file I only have a version of the command that worked. Now the other really useful thing about scripts is that you can add comments. So the way we add comments is with a hash key, and then anything after the hash key, hash symbol, is treated like information. So I can say add two vectors together. Let's put it above this one actually. So commenting your code is a really important and useful habit to develop, because it means that you will have a record of what you did and why you did it, as well as the actual code. So it's like a lab book of code as well as the actual code. So at the end of the session, you'll have a script file which has not only all the commands that works, but all the comments that you wrote to help you understand what was going on. So obviously you're going to want to save that. And in order to save it, it's a good idea to set your working directory. Your working directory in R is the place where R is going to look for anything you ask for, any files you ask for, and save any files you ask for. So the easiest way to set your working directory is to use session, set working directory, choose a directory, and then just pick a directory that you want to use. So you can see down here that this command has appeared, set WD. So set WD stands for set working directory, and this is the command I could have written in my script or at the command line instead of using the menu commands to set my working directory. So if you want to keep a record of absolutely everything you did in your session, you might well want to include that text in your script file. And you can do that by highlighting the command in history, making a space for it in the script file, and just doing to source. And you can see now that command that you wrote, that you used the menu to create, now appears in your script file. So then to save your script file, you just go File, Save, and I'm going to choose save it as my first script. Dot capital R, and .r is the extension for all R script files. So they're the files that RStudio will recognise as script files as opposed to any other files that R might recognise. That means you can then open this script file on another day and rerun all the commands. And that's it for today. Bye bye!